Hello everyone, this is Srinivasan, a enthusiast, ML evangelist, and a former student of Udacity Nano Degree program. I am excited to talk about neural networks, one of the hottest topics in artificial intelligence today. Neural networks are the foundation for some of the advanced AI concepts, including deep learning and reinforcement learning. Before I dive into the details of neural networks, here is a little bit of background. Neural networks have been in existence for more than 50 years, and so the concept is nothing new. After an initial excitement in the academia, there was a lull in the development of neural networks for a few decades before neural networks became popular again in the late 90s and the early part of this century. The sudden spurt in the development of neural networks is due to two reasons. Number one, the availability of data, a lot of data, and number two, the availability of low cost and high performance computing, including the GPUs. Neural networks are fascinating for the following reasons. Number one, neural networks are general purpose in nature as they can model any linear or non-linear phenomenon. Number two, neural networks form the base for some of the advanced AI concepts like CNN or convolutional neural network and deep learning, the most powerful and popular techniques used for image recognition and speech recognition. So, without further ado, let's dive into neural networks.
The fundamental building block of neural networks is called a perceptron. Perceptron, in its simplest form, takes one input x and produces an output y in the form of y equal to wx, where w is a weight multiplied with the input x to produce the output y. Now we all know from linear algebra this represents a straight line passing through the origin with a slope of w. By adding a constant b, which is also called the y-intercept or bias in machine learning parlance, we can make this equation to represent any straight line passing through any point on the y-intercept. Now, by adding this bias term as another input to our simple perceptron, we can model a simple linear equation representing a straight line using our perceptron. To our simple perceptron model, by adding more inputs, x1, x2, all the way up to xn with our bias term, we produce an output y in the form of w1 x1 plus w2 x2 all the way up to wn xn plus b. We have a linear equation in n variables, which is now more powerful than the simple model that we have seen before. Now, this can solve any linear regression problem in n variables. Now, to make this much more general purpose and also to solve classification and nonlinear phenomena, what do? Let's look at the next. Now let's go back to a simple perceptron model with one input X and a bias term B. Now to that, let's add a simple element called an activation function to produce an output Y. Now this activation function will generate the output Y only for some specific combination of B and X and will turn it off for the rest. Let's look at one simple activation function to see how it works. The simplest of the activation function is called a step function, which generates an output Y only for input values beyond a threshold. Now this, when combined with our earlier simple linear equation of y equal to wx plus b, produces a more powerful nonlinear model which generates an output y equal to wx plus b only for some specific threshold greater than or equal to 0 and 0 otherwise. So just by adding an activation function, we have converted our linear equation into a nonlinear model. Now this simple nonlinear model can be used to solve our classification problems. By combining such simple perceptrons into a network of nodes, we create what is called an artificial neural network. Now the set of inputs is called an input layer and the outputs an output layer, and the ones in between are called the hidden layers. Now by modifying the depth and the width of the neural network, we can model complex real-world phenomena to solve both classification and regression problems. Now, why are they called neural networks? For that, we need to understand how our brain works. The fundamental element of our brain is what is called a neuron. Which is made up of what is called a nucleus and a set of dendrites and what is called an axon that connects to other neurons. Now the nucleus takes inputs through the dendrites and beyond some threshold it fires, and the output of that is passed through the axon to the next neuron. By having such a complex web of neurons, our brain can function in a very complex fashion to visualize an image or listen to music or do multiple things, and that's the reason why our model, which is pretty similar to the way the brain works, is called a neural network, and more correctly an artificial neural network.
So, that's a quick introduction to neural networks. By the way, I haven't touched upon some important concepts like training. How do you find the weights and biases that produce an acceptable output? More of that in my next video. Stay tuned. Bye.